Here's a great chance for us to brush up on our synthetic division. Now, in synthetic division, first off, you don't divide by the factor, you divide by the root. Now, what we mean by that, let's just say we had x squared plus 9x plus 20 equals 0. If we factor that, the two numbers that add to 9 and multiply to 20 are 4 and 5. So we'd have x plus 4, x plus 5 equals 0. Those are your factors right there in parentheses. Now we can use from here the zero product rule, which is the idea that if those two parentheses multiply to 0, then that could only have happened if one of the parentheses themselves was equal to 0. So you solve each of those out, and you get -4 and -5. So if you have a factor of x plus 4, you have a root of x equals -4. A factor of x plus 5, a root of x equals -5. If you had a factor of x minus 2, you would end up with a root of x equals +2. So on these simple binomials, it flips the sign over. So our root in this situation is, for the denominator, is x equals +3. Because what we're doing here is we're taking this and we're dividing by x minus 3. Synthetic division, which we're going to show you right now, is a shorter way to do that, but you need to know what the root is. If the factor that you're dividing by is x minus 3, then what's going to actually go in the synthetic division box is +3. So we're going to put that 3 right there. And for synthetic division, you need the 3 coefficients of the things that you're dividing. 1, -2, and -5. So 1 minus 2 minus 5. The next thing you do is you bring the first number here down to your answer. So that 1, you're going to bring it down. Now, what you want to be telling yourself in your head when you do synthetic division is multiply, add, multiply, add. That's really what you want to say. So let's do it. Multiply 3 times 1, add -2 times 3. Multiply 3 times this number 1, add -5 and 3. So when you're doing this, the very last number you get, that's your remainder. The next number is your number, your constant at the end. The next number is your x. And if there was another number, that would be the coefficient in front of x squared and x third and so on. So we have 1x plus 1 with a remainder of -2. Now, if you remember from when you learned long division in middle school, the remainder goes above the denominator. So just quick example there. Let's say we had 10 divided by 15. Okay, well, you need 2 15s to get to 30. 3 15s would have gotten you to 45, so that would have been too big. That would have been too big. So 15 times 2 is 30. Then you subtract, and you get 11. How many 15s? Okay, well, by the way, now you bring down another 0. And so we're thinking, how many 15s do we need to get to 110? And the answer is you need 7 of them. And now you're multiplying 7 times the 15, which is 105. So when we put that 7 there, 7 times 15 is 105. And then when we subtract, we get 5. So the answer is 27 remainder 5, which can also be written as 27 and 5 over the thing you're dividing by. In other words, 27 and 1/3. So this is how remainders work in division, how you can make your remainder part of the actual answer in a classic format. So here, if we have x plus 1 remainder -2, that's the same as x plus 1 minus 2 over the thing you're dividing by, x minus 3. X plus 1 minus 2 over x minus 3 is answer choice D here.